Alright, this is Claude here. Let me explain to you what's going on. So in this networking course here, I am actually trying to learn how to network different devices together. So what you see here is me basically dialed into 4 different routers, and they're represented in the different colors. And to give you an idea of the routers that are dialed in, to give you a make-believe view of their locations, I'm going to give you this here map. So the devices connected that I'll be dealing with is R1, R2, and R3, and R4. And as you see, they're overlaid over this map to give you a make-believe feel in this here specific lab as far as their locations. The R1 that's out here towards the Oregon-Idaho area is actually represented by this window that's in the orange text. The router that's represented here that's in the South Dakota area is represented in this blue text. The router that's represented R3 that's over here that's Pennsylvania, Ohio, I believe, or yeah, that's around Pennsylvania, Ohio area. That is actually represented by this here yellow text down here. And this last router down here, R4, as you see, that's in Texas, which is represented in this here white text. So back during the static route, I had to teach these routers to talk to one another by giving them a specific path that allowed them to ping traffic back and forth to one another. Dynamic routing is actually a way of having the router teach itself, which is a lot more efficient. The static routing was okay for the learning environment that I was in because it was limited devices. As we all know, the world is not limited by the amount of devices, and actually is actually growing and will continue to grow as we become more and more technologically advanced. But the dynamic routing actually allows the router to learn its own path, whether Oregon needs to talk down here to Texas, or whether Oregon needs to circumvent the entire country and talk over here to Pennsylvania. So that's basically what this here lab is about. So what I'm going to do is I'm going to actually, to expedite this, I'm actually going to preload a script to actually give a few basic IP addresses to these here routers. So just bear with me for a hot minute. So as you see here, I'm preloading certain router configurations. And as you see, the links are coming up here as it realizes R2 is actually waking up. So we'll let that do that. Put number 3 in. And a router down there in Texas. Let me put that in. Okay, so as these routers load their parameters, like I said, this is just basic configurations that's going on. I'm going to do a interface brief, get an idea, make sure these IPs are set like they're supposed to be, make sure the protocols are up like they're supposed to be, which everything looks good so far. Okay, so with this, Now the actual work of teaching these routers begins. So what I'm going to do, I take that. Let me see. Hold on a second. Let me just test something real quick. So the routers just have their IP addresses set up. So let me see. Router 1, I'm going to try to ping router 2, which is in South Dakota. I'm going to try to ping it from Oregon, which is router 1. And this actually should not work. Okay, it does. It's directly connected, so it's the next one. So, right, I learned networks connected directly to each other. In this case, R1, R2 should be able to talk to one another. Now, what I should have a problem with is a network that is not directly connected. So, an example, R4 or R3, because it has to go through some other devices in order for R1 to talk to us. So what I'm going to do is I'm going to try to ping R3, which is over here in Pennsylvania, which is 10.2.2.2. So let me try that. Okay, and as you see here, I didn't get 100% success like that, like you see there. So this is having a problem trying to ping R4. Oh, I'm sorry, R3. And this is going to time out in a minute. So this is just reiterating the fact that the routers have not learned how to talk to one another through the network. And it's still trying, so there's 4 attempts here, and there should be one more attempt before it just gives up. Right, so as you see, that was 0%, 0 out of 5 attempts. It couldn't talk. But you saw it was 100% with his neighbor. So I'll take you to the picture. R1, which is here in Idaho, was able to talk to R2 because it's directly connected through the network. But trying to jump over and talk to R3 is where it had the problem. It doesn't know how to do that. And that's what I was able to do in the static routing portion of this here course, was to teach R1 how to reach R3 through R2. That's with static routing. That's when you have only a few devices, and static routing will allow you to do that. But when you have dynamic routing, this picture, this topology that you see here is extremely simple. So just imagine if you had R1 and R2, but you had 600 other routers in between there, or R2 and R3, and you had 600 routers in between there. It has to be able to learn its way through all those devices. And dynamic routing is a lot more efficient at doing that. So that's what I'm going to attempt here. Set up the basic configurations. This is going to be router RIP version 2. No auto basically just means the routers have a tendency that they want to update when they're in dynamic routing mode. They have a tendency they want to update themselves every 60 seconds, I believe. So basically it wants to relearn that path over and over again to make sure that it always knows where it's going. So here what I'm going to do is I'm going to go network, and what I'm going to have this do, I'm going to tell R1 which is here in Idaho, I'm going to tell R1, I need you to learn this here 10.1 network. I'm also going to need you to learn this here 10.2 network. I'm going to need you to learn this here this 192.168.30 dot network down here heading towards Texas. So that's what I'm going to program into it now. Let me get this out the way. Not dot 1, dot 0. And for the network down in Texas, which is 30.0. Okay, now here's the thing. Now R2, which sits here in South Dakota, like I said before, networks that are directly connected to one another have no problem with communicating. But just to lay the blanket over all four of these here networks, I'm going to have R2 learn about this here network that's the 192.168.10. So I'm going to do the same thing. I'm going to have it learn these networks around it. Tell it to learn these networks around it. So let me just set that up. Okay, still got to set up the same no auto. If I can type. Alright, so I need you to learn about the networks next to you and the ones not next to you. Oh, that's wrong. 92.168.30.0. Okay, now let me set this up for router 3. So router 3 out here in Pennsylvania has to learn about the networks out here towards the West Coast and in the Midwest and down here in Texas. So I need router 3 to learn about the 10.1 network, the 10.2 network, the 168.10 network, and the 168.30 network. So router 3 is probably going to have to do the most learning out of all of them. So let me set this one up down here in the yellow text. .168.10. I got a 168.30 down there in Texas. I need you to learn about that. I got the 10.1 networks over the Midwest. And for giggles, let's learn about the network that's going across Detroit. Okay, so got that set up. Now lastly, down here in Texas, R4 needs to learn about the networks, which would communicate through R2. Heading out towards the west, it would communicate with R1, and heading out towards the east, it would communicate with R3. So I got to set that up as well. Alright, so we're going to learn about the Dakota one, the 10.2. We're going to learn about the one on the West Coast. Stop screaming at me. Okay, that's the 10.68.10 network. We need to learn about the 10.2 network going out towards Pennsylvania. Okay, going to go ahead and end these and let these routers begin their learning process. And as you see, that's what their console comes back. So let me see if I can do a show IP route. And what you see, it shows me that, let me copy that command, paste them in the other ones. So basically what these routers are telling me now, they're spitting out information telling me what routes it went out to go learn about, and that's what it's giving me back the information for. So it's telling me, like, for example, that wait a minute, I might have missed something in number 4. But basically what they're telling me is that they learned the neighboring routes to get to the specific routers. So an example, what you see here is, I'm going to highlight this. This router learned about the 10.2 network through the 10.1 network. So basically what that's saying is R1, which is out here in South Dakota, no, I'm sorry, that's Idaho, Oregon, has actually learned about the 10.1 network. I'll take that back. R1 has learned about the 10.2 network, so it can talk to R3 through the 10.1.2 interface, which is R2. So basically what that's telling me is it's learned its path to R3 through R2. And it's doing it in one hop, which you'll see that number there, that's the 120/1. And it's saying that it's doing it through the routing information protocol, or RIP for short. So I'm thinking I got a problem down there on number 4. Number 4 is not getting me the information that I'm looking for. So I might have to redo number 4. Let me see. I don't think number 4 can ping. Well, let me see something real quick. So here, what I'm going to do, I'm going to test this theory. R1, I'm going to ping R3, and I should be able to communicate with it now. Before, if you remember earlier, they couldn't talk to each other because R2 was in the way. But now it's R1 has learned to use R2, so it should be able to talk to R3 now. R3 resides on 10.2.2.2, and we got a success rate of 100%. So when I go back up, you may remember when I did that same IP ping trying to talk out to the East Coast, it didn't happen because it didn't know anything about R2. But as you see now, it learned its path, and now it's able to ping that same address with 100% accuracy. So to give you a visual, R1 can now talk to R3 and send traffic to it, and it uses the protocol to go through R2 to do it. Okay, remember when I was saying I had a problem on R4 earlier? Because when I'm looking down here, R4 is not giving me the information, so R1 here is having a problem trying to talk down there to Texas. So what I may have to do is I may have to retype the commands in for R4 to learn its paths. Yeah, so I'm not going to get anything back from R1 right here. So R3 should be able to ping the West Coast. .1.1.1. Yeah, so that ping was okay. So R3 can talk. So I have a problem with R4. Now let me see. R2 should be able to talk either to the east or to the west. So let me just confirm that. Okay, that's good to the west. And now let me try to the east. And that's fine. But let me try Texas. But this should work because it's directly connected to it. Yeah. So R2 can talk to R4 because it's directly connected to it. That's a given. But R3 cannot talk to R4, or R1 cannot talk to R4. So basically the East Coast and the West Coast can't talk to Texas. So let me go ahead and set R4 up again because it wants to be a little difficult today. Hold on, wait, whoa. Okay, hold on, wait a minute. Version 2. No auto. What I got? Let me see. Let me pause this real quick. Okay, no auto. Network. Alright, I need you to learn 192. I need you to learn about the 10.1.1.0 network. Also need you to learn about the 2.2.0 network. Need you to learn about the 192.168.10.0 network. And that's it. So I want to see your IP routes. we still, so what am I missing here? What am I missing? What am I missing? Okay, here we go. So I had to actually have R4 learn itself again, the 130, the 168.30, and then that took it through. So it learned about the 2 and the 10.2, the 10.1 through the 30.1. So what that's saying is, to come from Texas, they had to learn about this point right here on R2, which is 192, 168, 30.1. From there, we can branch out to the West Coast and branch out to the East Coast. So let me ping R1 at 10.1.1.1, and we should be successful with that. It's a little slow, but yeah, we got 100%. If we try it again, now that it knows the route, it should be a lot faster. Not that much, but okay. And we should be able to ping the East Coast over here at 10.2.2.2. There we go. Okay, so now R1 can talk to R4. R3, let's see if we can talk to R4. 192, 168, 30.2. So we're going to go from Pennsylvania to Texas with this one. And success rate 100%. So we got full connectivity between the 4 different routers in the 4 different locations, basically by using the RIP version 2 protocol and having the routers learn themselves instead of me assigning static routes and static paths for them to go through.